Welcome to another informative episode of AWS Solution Architect Associate Exam Question Series on Exam Tricks and Tips channel. Please like, share, and subscribe to get regular updates on new episode releases. Welcome to episode 9. We will cover questions 41 to 45 in this episode. For questions 1 to 40, please refer to previous episodes of this series. Let's get started. Question number 41. AWS is used by an e-commerce firm to operate a multi-tier application. Amazon EC2 hosts both the front-end and back-end layers, while Amazon RDS for MySQL hosts the database. The back-end tier is responsible for communication with RDS instance. There are so many requests to the database to get identical datasets, which results in performance slowdowns. Which actions should be performed to optimize the back-end performance? So let's understand the problem description here. We have an e-commerce firm which is using EC2 as its compute tech stack, and it's talking to RDS database, and it is requesting identical data sets on regular basis. And this situation is causing overall degradation in the performance of overall solution. We have done similar problems in past. Whenever we have a situation where we are requesting identical data sets on regular basis from a database, the solution is to have some sort of caching. And that's what we're going to try here. So in this solution, between our Amazon EC2 compute and Amazon RDS database, we're going to place an elastic cache. Whenever the system, e-commerce system is requesting identical data sets, first it will look in cache, and if it finds that data over there, then it's going to use it from the cache. So there won't be a requirement to go to database all the way. If in case a non-identical data set, something that is not already cache, has been requested, then obviously the request will be sent to RDS, and then depending on how many times that data is being requested, if it qualifies for caching, it will remain in elastic cache, and then next time when the e-commerce application requests that, it will come from elastic cache. So essentially, the overall solution will be anything that is required frequently, any data that is requested repeatedly because it's identical, then it will be fetched from elastic cache. And anything that is new and not identical to previously fetched data, those are the only requests which will go to RDS database. So with this arrangement, what will happen is number of requests going to RDS will be low, and it will help to improve the overall performance of the solution. And our current problem of slowdown will disappear. So that's our solution. Anytime you see identical data being fetched repeatedly, the data that is not changing being fetched repeatedly, instead of getting every time from database, you should use some kind of caching solution and get the data from cache. So that will be the solution here. Let's look at what options we have. So we have one caching option here, elastic cache. So that's the one we've just discussed. Let's go through other options as well, and let's figure out why they are not the correct options. So first one, option A says implement Amazon SNS to store database calls. This is incorrect because SNS is a notification service. It's nothing to do with caching. It's not going to help you with database request or identical data request from the RDS database. So that's wrong, absolutely wrong. Second one wrong for me. Option C says implement an RDS for MySQL read replica to cache database calls. Now this is also some sort of caching solution. However, this is incorrect. Read replica is used for read scaling, not caching. So this particular option is saying use read replica for caching the database calls. That's not how it works. You use read replica in when you want to separate the load, and typically it is making sure that transactional load goes to the main database, and reporting load, any sort of analytics queries which can be done on a offline database, those are done using replica. So that's a different scenario. That's again a exam tip. Whenever you see a database being used for multiple purposes like transactional load as well as business analyst queries or reporting queries, you can always separate it out, use read replica, connect the reporting application to read replica. But that's a different scenario. In this case, it's an incorrect option. So we'll rule that out. Option D, implement Kinesis data firehose to stream the calls to the database. It's incorrect because Kinesis data firehose is not a caching solution, is not used for optimizing database calls. It's used mainly for streaming data to data lakes and analytics systems. So wherever you are building data lakes for running complex reporting queries, data firehose can be used to stream data from the source of the data to the data lake. For example, you can have some sort of IoT devices which are producing data every now and then, and that data needs to be put in a data lake for queries and reporting. Then you can use Kinesis data firehose, but not for caching. So that's incorrect. So that's wrong as well. And that leaves us with option B, which we have already discussed in the previous slides about during the solution overview, that this is the right solution. You can use Elastic Cache to cache large data sets retrieved from the databases. It would optimize the backend performance by reducing the number of identical calls made to the RDS database. This is our correct answer, option B, use Elastic Cache. That's it on this question. Let's move on to the next question. Question number 42. A business's on-prem data center has reached its storage limit. The organization wishes to shift its storage system to AWS while keeping bandwidth cost as low as possible. The solution must enable rapid and cost-free data retrieval. How are these stipulations to be met? So let's look at the main keyword here. So we have a situation where we have an on-prem data center and the data storage limit has been reached here. The organization wishes to shift its storage system to AWS while keeping bandwidth cost as low as possible. And what are the solutions that we should be exploring in this case? I believe we have done a similar problem in past, but let's go through this. Let's eliminate the wrong options and we'll select the correct answer after that. So first option says deploy Amazon S3 Glacier Vault and enable expedite retrieval. Enable provision retrieval capacity for the workload. So S3 Glacier is an archiving solution. If you look at our problem description, we need to keep cost low, which is fine. S3 Glacier is cheaper, but we also need to make sure that we have rapid and cost-free data retrieval, which is not going to be the case. It's get data retrieval in case of Glacier is not immediate. There is latency and it will incur charges. So that's wrong. Let's look at what other options we have here. So option C uses AWS Storage Data Gateway. Option B is also using Storage Gateway. And option D is using Direct Connect to connect on-prem with AWS. And it's again using AWS Storage Gateway later. Considering B, C, D, all are using Storage Gateway. That's the correct answer. And we know whenever you have a requirement, you need to increase the storage capacity of on-prem data center, you can use AWS Storage Gateway. You can use AWS Storage Gateway, which can point to S3, and you can have virtually unlimited data storage using this solution. So AWS Storage Gateway is the answer, but what variation of it that we'll have to select. Now between options C and D, I think I will rule out D for sure, because if we need storage gateway as a solution, in that case, we don't need direct connect because storage gateway is good enough to point to S3 in AWS and back up the data. So D is wrong from that perspective. We don't need it. Plus, there is one more reason why D is wrong. But let me analyze C based on that particular criteria. Now, in this case, what we have is in the first statement of the problem, what has been mentioned is data center has reached its storage limit. So when you use storage gateway, you cannot store the data locally. Option C says use your storage gateway and then store data locally. We don't have any local storage. So this is not possible. So any option in remaining options which says that we need to store data locally is wrong. So for that reason, option C is wrong. We cannot store data locally. And if you see, look at option D as well. Over there as well, we have been told that we have to store data locally, but that one I am ruling out just on the basis of AWS Direct Connect. We don't need AWS Direct Connect for once we have AWS storage gateway. So option C is ruled out. Option D is ruled out because of Direct Connect. Option C is ruled out because of storing data locally option. And that leaves us with option B, which says, okay, deploy AWS storage gateway with cached volumes. Now that means we are not storing data locally. Use storage gateway to store data in S3 while retaining copies of frequently accessed data subsets locally. So AWS storage gateway cached volume mode stores frequently accessed data subset locally while storing the full data set. Now this means this caching option of AWS storage gateway makes it possible to optimize the bandwidth. The bandwidth cost will be low because anything that is frequently accessed will not be making a full journey of going to storage gateway and then to S3. It will be cached in AWS storage gateway using cache volumes. In fact, that will also help with the fast retrieval. So all requirements are met in this option. We are using storage gateway as a solution for storage, and we are using it in a cache volume mode. That's going to help with keeping the bandwidth low as well as fast retrieval. And overall cost will also be lower because we are not going to S3 for every retrieval because of caching solution. So option B is the correct answer for this particular question. Question number 43. Every day a business processes data. The process output is kept in an Amazon S3 bucket, examined daily for 1 week, and then must remain readily available for ad hoc examination. Which storage option is most cost-effective alternative to the existing configuration? So this is a S3 storage class conversation. let's understand the problem description. What we are saying is we have an Amazon S3 standard bucket being used for storage, and the data is examined daily for 1 week. So for 1 week, data is frequently used. So this is an important bit. And after that, we don't access it very regularly. It's only, but it needs to be readily available for ad hoc examination. So initial requirement for a week is data is frequently accessed. Then we can move it into a storage class, which is cheaper. So we can have some sort of life cycle policy and move data to another storage class of S3. It could be any of these three that we have. We haven't yet figured out which option we'll go for. And we want to save the cost. So one thing is for sure, after the job is done, which is 1 week here, but we won't really go for 1 week. The optimum period is 30 days as a standard policy. So after 30 days, we don't need data frequently. We need to move it to a cheaper storage option in S3 storage class. So that's the answer. Now we need to figure out what is that storage class. And now let's look at the requirement. We need data readily available. So when you say readily available, we are not talking about Glacier. We are not talking about deep archival. So Glacier will be ruled out for that reason. Then we will be left with IA and one zone IA. Now between those two options, both are similar, both are infrequent access, so the cost is lower. In case of one zone IA, it's even cheaper, but that is at the cost of availability. And I think we don't want to be compromising on availability. So I think the better answer is you do a lifecycle policy, move data to S3 standard IA with so infrequent access, and that would give you an optimum trade-off between cost-effective solution, something that is readily accessible in terms of data, as well as it's highly available because you're not compromising on number of availability zones. You're not putting it in one zone, you're keeping it in standard 3 zones. So that will be an overall solution overview from my side. Let's look at what options we have. So first one option here is nothing to do with storage classes. It basically says, let's create a lifecycle policy to delete the objects after 30 days. So this will be cost effective. Obviously, you're not storing data after 30 days, you are basically deleting it, but it doesn't conform to the requirement that we have is after 7 days of initial examination, we want data to be readily available for ad hoc examination. So we do need data after that initial period of 7 days. So we cannot delete the data. So option one is wrong. So we rule option A for that reason. Then option B says, let's move it to S3 Glacier after 30 days. And we just discussed, we cannot use S3 Glacier here because we want the data to be available readily. If we move the data to Glacier, we cannot get it available. It won't be available to you readily. It will be almost minutes to hours if you need some data from S3 Glacier. So that's ruled out. Then we have option D, which says, let's move the data to single availability zone, infrequent I. Now, as we've said, this will be a problem in case this option basically reduces the availability for you. I don't think we should be reducing any availability. We have an option, which is option C, where you can move data from S3 standard storage class to S3 standard infrequent access, which is a correct and optimum solution from an cost reduction perspective. Also, we're not compromising any high availability, and we're making sure that overall solution is resilient. So that's our answer. Option C is the answer for this particular question, standard I after 30 days. And just to reinforce the fact, I have this diagram about S3 storage classes. Starting from left, we have S3 standard storage class, and moving to the right, we have intelligent tiering, standard IA, one zone IA, Glacier, Glacier Deep Archive. As we move from left to right, the data access frequency expectation is going to be lower. So from a frequent data access, it keeps moving to infrequent data access. The cost from left to right reduces because you're going for a cheaper solutions, a solution where you don't get immediate access to your data as you move from left to right. Also, generally, yeah, it's becoming cheaper. And we have gone from this particular S3 standard. We have skipped intelligent tiering because we don't want to use intelligent tiering if we know the access pattern. And in this particular question, we know the access pattern. In case they had said, we do not know how the data will be accessed, then we would leave the job of tiering the data in different categories to S3 by using intelligent tiering, but that's not required here. We have gone for this solution, which is a better option in terms of this particular problem scenario. And this is the reason Why we have gone for this? We have millisecond access for standard IA. So that conforms to the readily availability requirement in our question. In case of zone 1 IA, we eliminated this particular option from our available options because the data is stored in single AZ, and we eliminated Glacier because when we want data, it might take minutes to hours, which doesn't conform to our requirement of immediate access. So that's it on this question. Let's move on to next question. Before moving on to the next question, if you're finding this analysis and discussion useful, then please hit that subscribe button if you're not already done it. Thank you. Question number 44. A new employee has been hired as a deployment engineer by a corporation. The deployment engineer will construct several AWS resources using AWS CloudFormation templates. A solution architect which desires that the deployment engineer execute job functions with at least amount of privilege possible. Which steps should the solution architect do in conjunction to reach this goal? We need to select the two options from the given I options. So let's understand problem description here. We have a new employee. He joined this new organization. And as an administrator, we need to give him access to our resources, AWS resources in this case. And we are trying to figure out what level of access we need to give this particular deployment engineer. One of the guidance they have given, which is in fact the guiding principle of how you should be managing identity and access permissions in any situation, is give least amount of privileges possible. Do not give anything more than the person or the user needs to do his or her job. So let's look at what will be the solution. So what we don't want to do is just give this person keys to the whole premises. He has a particular role in this organization. Let's not hand over him everything. First of all, he doesn't need it. And if the person has incorrect intention, then obviously you are subjected to a security breach and you could lose data. You could lose valuable information in your organization. So that's what we want to avoid. That's the danger. And how do we do that? Is instead of giving unnecessary access to this particular user, use the least privilege permission principle and only give what this person or the user needs. Give only what this user needs. Give minimum permissions and give permissions that are required to do the job. And that's about it, nothing more than that. And that would take away the problem of security risk. And that's the correct approach. So that's what we're going to do. Let's see in the options what scenarios we have in terms of solutions and which solution is conforming to least privilege permissions. So we have multiple options here. Let's go through each of these one by one. The first one says, let's give root credentials to this particular user for performing its job of CloudFormation stack operations. Now, that's that's a strict no-no. We do not want to assign root credentials. Root credentials means the user will have access to everything. That's a major security risk. So that's wrong. Second option, which is option B, says, let's make him power user. Let's attach power user policy to the group that user belongs to. Again, that is not conforming to privilege to principle of least privileges. We don't want to give excessive permissions to this particular user, so we cannot make him a power user. That's wrong as well. So option B is ruled out. And third one is saying, okay, let's make him administrator. So again, this is a wrong option. We cannot make or attach this user to a group which has administrator access policy. That is going to be inappropriate because the user doesn't need that access. So this is a fairly simple and a very logical question. You don't need to even know AWS knowledge for answering this question. It's simple. Give only necessary permissions to the user. And that has left us with only two options here. Option D says, add user to a group that has an IAM policy that allows AWS CloudFormation actions only. Now, this is what exactly the user is supposed to do. He needs to be having access to CloudFormation actions. So option D gives him that particular access. So that's a correct answer. And option E says, create an IAM role for the deployment engineer to explicitly define the permissions specific to the AWS CloudFormation tasks. Now, here we are saying that, make a role itself to create a role that only allows permissions for doing CloudFormation stack related tasks. So this is another good option. So between D and E, you are, sticking with the principle of least privileges and you are giving access to this user as per that particular principle, you are giving him access only for CloudFormation actions. So this is the correct answer for this particular question. For your benefit, I'm referring you to an article from AWS documentation, and it talks about applying least privilege permissions using IAM practices. So please go through it, make yourself familiar with this article. That's it on this question. Let's move on to the next question. A corporation is using AWS to construct a new machine learning model solution. The models are constructed as self-contained microservices that get around 1 GB of model data from Amazon S3 and put it into memory during startup. These models are accessed by users through an asynchronous API. Users may submit a single request or a batch of requests and designate the destination for results. Hundreds of people benefit from the company's models. The models' use habits are erratic. Certain models may go days or weeks without being used. Other models may get hundreds of queries concurrently. Which solution satisfies these criteria? It's a very wordy, long question. Let's understand this question from a problem overview perspective. So what we have here is there are some machine learning models which are stored in Amazon S3. Its model size is about 1 gigabytes. And these machine learning models are loaded in memory at runtime. And these machine learning models are accessed by users. And the users are using asynchronous APIs to access these models. The usage patterns and habits are erratic. As you can see, one model on the top is being used by, say, 3 users, whereas the models at the bottom, they are being used by a lot many users, whereas the last one, nobody's accessing. So the usage pattern is erratic and is being accessed by asynchronous APIs. Now you need to sort out this and make sure that this becomes, you provide a solution for all of this where you are conforming to the requirements. You are also making it to be a performance solution. The key point here is in terms of performance access is the models may get, the access to the models is very erratic and there could be hundreds of people also accessing a certain model. So we don't want that model to be slowed down because it's getting more requests. In order to design this solution, we need to look at what's happening here. We have asynchronous APIs. That means we don't need an immediate update from users in terms of machine learning model. They can wait. So whenever we have asynchronous APIs, we should decouple the solution. And for that, we should use SQS. That's the best option. We need to decouple it, use SQS. And for models usage being very erratic, that means the load that we are going to get on this solution is not predictable. That means we need some sort of auto scaling. So first we take SQS where all the users will give their request and SQS will manage the request distribution to the overall solution. And in terms of compute, in this case, we will use a serverless option, which is AWS ECS, which will take requests from SQS and then it will run all of these models, which is stored in S3. And I think this will provide us an optimal solution to us in terms of decoupling the overall solution and making sure that we solve the situation where a lot of asynchronous API requests are being made. And we also solve the issue around erratic usage from different users and imbalance load each of the models that are getting. So I think this will be kind of an overall premise of my solution. Let's see what options we have and how close we are in terms of these options and do we need any tweaks in the final answer. Because this question is very wordy, I'm just capturing options here. So we have 4 options here. Let's see what we have. Now the first option says the requests from APIs are sent to an application load balancer. Models are deployed as AWS Lambda function invoked by ALB. Now Lambda function won't be able to scale well horizontally for concurrent requests and it will have limitation with memory allocation. So this is not a correct answer. I think the first one and one of the most important bit we are missing here is we have asynchronous APIs and we are not even trying to decouple it. I would always decouple a solution using a decoupling solution like SQS whenever there is a opportunity for it. I think that allows you your solution very cost effective. It guarantees the performance as long as you are putting the right resources in the right architectural framework. Option A is wrong. It's not going to work. Option B says the request from APIs are sent to the Amazon SQS. Models are deployed using AWS Lambda function triggered by SQS events, and AWS auto scaling is enabled on Lambda to increase the number of vCPUs on the SQS size. So from an SQS perspective, I think this option is using the right service for decoupling. What I'm happy about is usage of Lambda and autoscaling. While autoscaling on Lambda based on SQS size is possible, it might not be as cost effective for large containers and may have, cold start latency issue, and that could cause performance issues as well. So SQS perspective, this option is correct, but I think in terms of the compute solution, autoscaling, that part of the solution is not correct. So we will rule that out. Option C again is using SQS, which is correct. Models are deployed as ECS services, which is fine, but reading from the queue, AWS AppMesh scales the instances of ECS cluster based on the SQS queue size. Now, AppMesh has a different purpose. It, first of all, added complexity here. We don't need AppMesh. We can do the job with a SQS and ECS container. So this is an incorrect option, and we'll look at AppMesh briefly after we get our final answer. Now, option D, which appears to be the correct option here, it is using SQS queues, and models are deployed as ECS services reading from the queue. AWS autoscaling is enabled on ECS for both the cluster and the copies of service based on the queue size. Now, this is a perfect solution. You're using two services, SQS and ECS, and configuring autoscaling on ECS, which is giving you the right capacity when needed. So this way you are resolving the asynchronous APIs requirement by deploying SQS, which is available in even option B and C. And you are also solving the problem of different load being subjected to different models, machine learning models from the users. So because you're using a serverless service, which then you are configuring in an autoscaling mode, this is the perfect solution. So option D is the correct answer for this question. Let's look at the answer from an advantages and overall analysis perspective. So this particular option has asynchronous APIs and it caters for erratic use. So SQS will buffer the requests asynchronously, handling both single and batch type of queries effectively. The asynchronous nature aligns with the API needs. The SQS itself is an asynchronous service, and APIs are expected to be asynchronous. Cost effectiveness, auto scaling on both the ECS cluster and the service copies dynamically adjusts container instances based on the SQS queue size. This ensures efficient resource utilization, low usage during the low usage period, and then scales up to handle concurrent requests effectively. Containerized microservices, that's the third element here. ECS enables deploying the models as self-contained microservices, aligning with the architecture requirement. And the last one, large model data in memory. So we saw that the memory size required for models was almost up to 1 GB. So ECS containers offer more control over memory allocation compared to Lambda function. I think that's one of the reasons why ECS containers are better than Lambda in this particular situation. And they're potentially suited better for the model size, which is as large as 1 GB. That's our overall analysis of the selected answer. In terms of a new service that we have seen, AWS App Mesh, that's the new service we have seen. It is used for application level networking for all your services. So if you need some sort of internal networking of your application components, you can use AWS App Mesh. It streamlines operations, implements the custom traffic routing rules, and configures standardize how traffic flows between your services. Now, this looks like a completely a different use case than what we were doing there. So that's the reason why we ruled out that option, which was, I think, option C, which was using an additional service of AppMesh, which has no reason or no place in this particular solution. That's it on this question. And I believe this is the last question in this particular episode. I'll see you in the next episode of this series. Thank you. This is Exam Tricks and Tips. You're watching AWS Solution Architect Associate Question Series. See you in the next episode. Thanks for watching.